For the second part of this video, it's asking us to find the intercept form and then the standard form of each of these two graphs. Now, since we're doing the intercept form, let's just right away go and say what the intercept form is for our red graph on the left, and we'll go through that, and then I'm going to ask you to do the blue graph on the right. Firstly, for A of this first graph, the x-intercepts are identified as -7, 0 and -1, 0. It means, mathematically speaking, we would say our x integer is either -7 or x is equal to -1. Now, based on that, we can go and say that our equation is y is equal to a, because we don't know what our stretch is, and then we write x. Oh, wait a second. Instead of having x is equal to 7, remember, we're still using that 0 rule, that opposite rule, to create this. So we end up with x plus 7, and then x, instead of -1, we end up with +1, because we're using our opposite world rule to generate it. Now that I've got my general intercept form, we have this beautiful thing down here. We have this beautiful highlighted thing here. That point is -4, -9. Let's sub -4, -9, -4, -9 into, let's call that equation 1. And we're going to get something like this. -9 is equal to little a times -4 plus 7, and then -4 plus 1. Now, we end up with -9 is equal to a times, well, -4 plus 7 is 3. -4 plus 1 is going to be -3. When we simplify the right side of our equation, we end up with a times -9 and -9. Now, this is where some of you guys forget. If I have a times -9, what you do is you just make it as -9a. Now, solve for a, you end up with a equaling 1. Because if you think about it, a is equal to -9 over -9, which turns into 1 in that case. So now that I have my a value, you're going to go and state your intercept form. This. And we're just going to substitute what we just got for our a value into our equation. I'm just going to put a 1 there. 1, and then we have x, well, plus 7 as before. Okay, and then we have x plus 1. And now, remember, that is a. So B is asking for the vertex form of our parabola. Oh, the standard form of our parabola. So when we do the standard form, all we have to do is expand this equation. So you start with y is equal to x plus 7, x plus 1. When you expand, you're going to get x squared plus 1x plus 7x plus 7. And we end up with y is equal to x squared plus 8x plus 7 as our standard form. Now what I'd like you to do is do the same for the equation that you see here to our right. So our new blue graph to the right has 2 points. Let's all say let's all agree that our x-intercepts are, well, I got a 4, 0 here, and I have -2, 0 here. Do your calculations and I'll tell you what your solution should be. Now, there's 2 ways to do this problem. If you recall, I taught you about the step method a while back. Now, the step method says that for regular y equals x squared, the steps are going to be 1, 3, and 5. Now, if I had the step value for our alternate equation, say minus 2x squared, our numbers would be -2, -6, and -10. And if I look at this problem here, we could go over 1 and down 2. So guess what our steps are? The steps are these things here. Some of you guys like doing geometric solutions, but they don't always work. So if I was looking at this, I would follow the same patterns as I did before, and I would find out that my a value should be -2 in this case. So I'm thinking the a value is going to be -2. So let's just verify that. Now, it only works sometimes, so don't use that all the time. Bad things happen. Take care. Here we go. Let's begin. I'll show the solution, you tell, and we'll just verify. So you'll notice that now we have our x integers, our x-intercepts to be -2 and +4. Now when we construct our intercept form of this quadratic, we're going to have x + 2 and x - 4, the exact opposite of what you see for each number here. Then you'll notice we have our beautiful point here. Our beautiful point, 0, 16, being suggested as the point that we use because it is the only fixed point that we can see that we were given. You use that equation in your solution. So substitute 0, 16 into your equation and solve for a. So now you're going to get 16 is equal to a times, well, 0 + 2 is just 2, and 0 - 4 is going to be -4 when you substitute that in. So now we're going to simplify, and we end up with 16 is equal to a times, well, -2 times -4 is going to be -8. So that simplifies to -8a is 16. Bringing a down, we end up with a is 16 over -8, which means a is -2, as we suspected. Now, I would tell you that you can use this as a hint. You use the step method that I identified a while back by looking at the graph and analyzing it. You can use that as a hint to give you an idea if you're on the right track for your a value. And then you go and do the Xints, calculate just like this one, solve for your a, then state your intercept form. So we end up having -2 bracket x + 2 bracket x - 4. And now we're going to take that same equation and we're going to expand it using the concepts we learned in the previous chapter, i.e. factoring and expanding. So now we take our equation, y is equal to, well, -2. I usually leave that and I expand my quadratic. So I get x times x gives me x squared. And now x times 4 gives me negative 4x. And then 2 times x gives me plus 2x. And then 2 times negative 4 gives me minus 8. And then you end up with negative 2x squared minus 2x minus 8. And when we expand, our final standard form is take the 2 and distribute into every single term in this bracket to get the following. So we find that our standard form for this equation is negative 2 x squared plus 4x plus 16. And there you go. There you have it. So now let's move on to the final topic of today's lesson. So now, for example 4, it says an engineer is asked to design an archway into a new school building with this equation. Now this equation is interesting because if you think about this, I could rearrange this equation to be h is equal to, we could write that as h is equal to 16 minus d squared. Don't be afraid to rearrange your equations, because isn't this a perfect square? The square root of 16 is 4, and the square root of d squared is just d, right? So this is going to give us a difference of squares. So now, the big hint, when they go and ask you, hey man, how wide and tall is the arch? Well, we can figure out how wide this arch is by using the difference of squares to find the x-intercepts. So our original equation can be rewritten as h is equal to 16 minus d squared. When you factor that, you end up with, well, 4 minus d and 4 plus d. Now let's go back to the problem and identify some stuff that might give you guys some issues. So, the engineer is asked to design an archway into a new school building based on this equation, where h is the height in meters and the arch is the horizontal distance in the meters from the center. Now, because that's from the center, this gives us a hint. When we're talking about the hint, this might mean the AOS, the axis of symmetry of the parabola that this equation represents. So when we have this parabola, it says, how wide and tall is the arch? Well, if I end up with h is equal to this, so now what I could do is I could literally set that equal to 0 to find how wide it is by actually solving for d. In this case, my d intercepts are, well, 4 minus d is equal to 0, and the other one is 4 plus d is equal to 0. Solving for d, d is negative 4 on this one, and d is 4 on this one when you solve. Now, based on that, if we wanted to calculate our axis of symmetry for this, we're going to end up with, well, notice it's no longer x, it's d equals, and then we have 4 plus negative 4, and then we're going to divide that by 2, and that ends up being our d is equal to 0. Now, don't we normally take our axis of symmetry and substitute and back substitute into our original? Let's call this equation number 1 up here. So we're going to back substitute into it. So we're going to sub d equals 0 into 1 into equation number 1 there. All right. Into 1. By doing so, we end up with h is equal to 16 minus 0 squared. Uh-oh, the h value is 16. So, based on all that information that we just calculated, we have the following information. Now, we said if we want to find the distance between d is 4 and negative 4, that distance, that horizontal distance, is going to be 8 meters. And the height, based on our maximal y value calculation, i.e. taking our axis of symmetry and plugging back into our equation to find either the max or the min, and the height, the height maxed is 16 when d is equal to 0. And that's all she wrote, guys. That's it. So now, if you think about it, when we take a look at part B of our problem here, so that's this thing right here, you want to think of what's happening here. Based on our information, if we took a look at what our graph looks like based on all the calculations we did in part A, our graph is literally going to look something like this. Here's our x-axis, and then what we have is an arch that is centered about the x-axis, where our distance along the ground is negative 4 for our first intercept, and our second intercept is at 4. And that's how we ended up with a distance of 8 meters between those 2 points. And then our maximal value ends up at 16 on the h-axis. Okay? So, when we're talking about the arch, if I wanted to know what values d could take, the only values that d could take are literally in between negative 4 and positive 4, because any other points past that mean nothing to us, because we know that this part here, from here on, is the ground of our arch. Okay? That's it. So, in this case, we're going to say d is greater than or equal to negative 4 and less than, d is less than or equal to 4. So, we're essentially saying that our answer is literally between these two values. Between d is negative 4 and being less than or equal to d to the 4, d equaling 4. Now, for part C, what I'd like you to do is I'd like you to find a way to use this picture of our arch. Again, this picture of our arch with it being split down the middle. Remember, this is negative 4 and this is positive 4. So I guess this is 4, 0, and then this is negative 4, 0, and this point here up at the top is 0, 16. I want you to try and answer this question on your own. This is a special question that we'll try to look at later. If you're in class, we'll go over this. If you're not in class, you need to come and see me about this problem. All right. Now, I will not put this up online as a solution for part C. Your job is to work through it and see if you can come up with some way to fit a door or a number of doors that are 2.5 meters wide. When I want you to do this, I want you to consider the height of the door as well. So I want you to consider the height of the door as well. Height of door as well. Now, you guys are enriched. Take your time and work through this problem. And then we'll take it up together as a class. We'll have interesting discussions about it. Now, what I want you to do is I want you to do these specific questions. Okay? And I want you to do at least one of these. At least one. Do at least one of those questions. At least one of the extra challenge problems.